Hello everyone. Welcome back to our grade 6 mathematics class. In our previous class, we learned what pattern and sequences are. We also studied different types of number sequences. Today, we are going to see something even more interesting. We will understand how number sequences can be represented using simple pictures and how different sequences are connected to each other. Let's begin. Pair numbers. Look at this. I have a 1 dot. This represents the number 1. Now I arrange 4 dots in a square. Next I arrange 9 dots in a bigger square. Then 16 dot. And so on. So the numbers are 1, 4, 9, 16 and so on. Can anyone guess the next number? Yes, 25. They are called square numbers because the dots form a perfect square. So the rule is 1 into 1 is equal to 1, 2 into 2 is equal to 4, 3 into 3 is equal to 9, 4 into 4 is equal to 16, 5 into 5 is equal to 25 and so on. Triangular numbers. Look at this picture. The very first picture only one dot is there. In second picture a row is added with a 2 dot to the first picture. In third picture a row is added with a 3 dot to the second picture and so on. So the pattern 1, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus 4 plus 5 and so on. Do you see a triangle forming? That's why these numbers are called triangular numbers. So the sequence is 1, 3, 6, 10, 15, 21 and so on. Now let's move to cube numbers. Cube numbers are formed by multiplying a number by itself 3 times. The first 4 cube numbers are shown here. Let's learn another famous sequence, Fibonacci sequence. The Fibonacci sequence is a sequence of number 1, 1, 2, 3, 5, 8, 13 and so on. How do we get these numbers? To find the Fibonacci sequence, we start with the first 2 numbers 1 and 1. Now we add these 2 numbers. 1 plus 1 is equal to 2. So 2 is the next number. Next we add the last 2 numbers. 1 plus 2 is equal to 3. So 3 is the next number. Then we add 2 plus 3 is equal to 5. The next number is 5. Next 3 plus 5 is equal to 8. Then 5 plus 8 is equal to 13 and the pattern continues. So in the Fibonacci sequence, each number is obtained by adding the 2 previous numbers. Now let's discover a beautiful pattern. Let's add odd numbers. 1 is equal to 1, 1 plus 3 is equal to 4. 1 plus 3 plus 5 is equal to 9. 1 plus 3 plus 5 plus 7 is equal to 16. 1 plus 3 plus 5 plus 7 plus 9 is equal to 25, and so on. Here 1 represent 1 into 1 squares. 4 represent 1 plus 3 is equal to 4 represent 2 into 2 squares. 1 plus 3 plus 5 is equal to 9 represent 3 into 3 squares. 1 plus 3 plus 5 plus 7 is equal to 16 represent 4 into 4 squares. And 25 represent 5 into 5 squares. So these are square numbers. So when we keep adding odd numbers, we get square numbers. Now let's look some more exercise using pattern. Let's add 1. 1 plus 1 is equal to 2. 1 plus 1 plus 1 is equal to 3. 1 plus 1 plus 1 plus 1 is equal to 4. 1 plus 1 plus 1 plus 1 plus 1 is equal to 5, and so on. Here the answers we get are 1, 2, 3, 4, 5, and so on. These numbers are called counting numbers. Now let's add the counting numbers and see what pattern we get. 1 plus 2 is equal to 3. 1 plus 2 plus 3 is equal to 6. 1 plus 2 plus 3 plus 4 is equal to 10. 1 plus 2 plus 3 plus 4 plus 5 is equal to 15, and so on. When we add the counting numbers, we get the answer 1, 3, 6, 10, 15, and so on. What are these numbers called? Yes, these numbers are called triangular numbers. Now let's look at another interesting pattern. This time let's add consecutive triangular numbers and see what the result we get. What are consecutive triangular numbers? They are 1, 3, 6, 10, 15, and so on. Now let's add these numbers and see what pattern we get. 1 plus 3 is equal to 4. 3 plus 6 is equal to 9. 6 plus 10 is equal to 16. 10 plus 15 is equal to 25, and so on. When we add consecutive triangular numbers, we get 4, 9, 16, 25, and so on. Can you identify this pattern? What kind of numbers are these? Yes, that's right. These are called square numbers. Now we are going to learn about a special pattern of numbers called hexagonal numbers. Look at these figures. They are made using dots. And each new figure is growing by adding one more layer around the previous one. The first figure has only one dot. So the first hexagonal number is 1. In the second figure, we add a new layer around the center dot. There are 6 dots around the boundary. and one dot in the center. So the total 6 plus 1 equal to 7. In the next figure, we add another layer. New layer has 12 dot and including the previous 7 dot. So the total 19. Similarly, the next layer add 18 more dot. So 19 plus 18 is equal to 37. So the sequence of hexagonal number is 1, 7, 19, 37 and so on. Now let's observe the pattern. The difference between consecutive number is 7 minus 1 equal to 6. 19 minus 7 equal to 12. 37 minus 19 equal to 18. The differences are 6, 12, 18 and so on. Now find the differences again. 12 minus 6 is equal to 6. 18 minus 12 is equal to 6. The second difference is always 6. This tells us the hexagonal numbers follow a special pattern, just like square numbers and triangular numbers. But drawing dots every time is not practical. If we want to find the 5th, 6th, 10th hexagonal numbers, drawing a figure would be very difficult. So mathematicians use a formula. The formula Hn is equal to 3n into n minus 1 plus 1. Here n represents the position of the hexagonal number. For example, to find the 5th hexagonal number, so n is equal to 5. Hn H5 equal to 3 into 5 into 5 minus 1 plus 1 is equal to 3 into 5 into 5 minus 1 is equal to 4 plus 1. 5 into 4 20. 20 into 3 60. So equal to 60 plus 1 is equal to 61. So the 5th hexagonal number is 61. Using this formula, we can find the 10th, 50th or even 100th hexagonal number easily. That's all for today's class. I hope you understand the concept clearly. In our next class, we will continue. If you found this lesson helpful, please like this video, share it with your friends and don't forget to subscribe to the channel for more easy maths lesson. Thank you for watching.